communications data. Blast off with Nylas today.
Blag, good morning.
Hi, Marley, Ash, how are you?
Doing good, doing good. I'm ready to have my mind blown once again by you in terms of like getting introduced to something totally new.
Okay, let's go. So today we're going to talk about Racket, which is kind of a Lisp. So you're going to see in a second. And here it's kind of like a joke keyword of what you need to code in Lisp, right? So open and close parentheses.
Yeah, when you first showed this to me earlier, I thought, oh, that's got to be a little bit of hyperbole, right? But no, it's not. And I can't wait to see some of these lines of code that look kind of like this.
Yeah. So Racket, it's a functional, imperative, logic, meta, modular, object-oriented, and functional or reflective programming language. So it's kind of like a multi-paradigm. And it appeared on 1995, which is 27 years ago. And it's actually, Racket is a descendant from Scheme, which is a descendant from Lisp. So it's kind of like in the Lisp family of languages. And Racket actually inspired Clojure. So you see, we have all those languages that share mostly the love for parentheses. And
So
it can be installed using brew as always.
Yeah, that first bullet point, I'm just like, I kind of look at that and I'm, what does it mean to sort of have all of those descriptors for a language? Like, does that like in your day-to-day, like kind of have any bearing on how you're thinking about it? Or is this kind of a way of saying like, it kind of does a little bit of everything?
I think it's kind of like that. I mean, Racket comes with a language called Datalog, which is kind of like Prolog, so that would be logic. And also the kind of programming is kind of like functional, but I think you have also other languages, so you can do some object-oriented, you can do some modular. I'm not sure about meta. I think it means that you can do kind of like meta programming, right? Like enclosing a function inside a variable and then call the variable, or just call a function by its string name or something like that. So it's you can do a lot of things with Racket, but still it's kind of weird. Okay, so first operands. So in Python, we would say like 4 plus 5 by 3 is going to give us 19. If we want to do the sum first, we might need to put it between parentheses. 4, 5 by 3 is going to give us 27. But in Racket, the operator comes first. So what we need to do is, if we want to execute, obviously, the by first, we're going to put it in parentheses. So by 5, 3, and then on an outer parenthesis, we're going to have the plus and the 4. And that's going to give us 19. So for the 17, we would include in parentheses plus 4, 5, and on the outer one, it's going to be by 3. So pretty much the evaluation is going to go, I'm going to look into the inner parentheses, and then going to go out, 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 out until I get it.
So when you first showed me this, I felt like, okay, this feels kind of heartening because it's not that difficult to visually parse when presented with basic arithmetic. Like you said, the operand comes first. Kind of makes sense. It's just a different way of looking at the same thing.
Mm-hmm. Yeah, and it's at first glance, it's kind of like similar to fourth, but in fourth you would have like 4, 5 plus. In this case, you have the operand first. Then everything gets surrounded by parentheses, like everything. So here we are defining a function. So we say open parentheses, define, open parentheses, hello function, which is the name of the function, then the parameter, which is name, and we close parentheses. And then for the body, we surround it by parentheses. We do string append, which is gonna just grab 2 strings and append them together. Hello, and then the parameter name. So we obviously close the parentheses. But then when we want to call that function, it's also surrounded by parentheses. So we have open parentheses, hello function, which is the name of the function, and then Blag, which is going to be the parameter, and then we close the parentheses.
And I suppose for this, the white space is meaningful.
No, not really.
Interesting, because I guess I just found myself curious, like if you don't have that sort of tab or spaces under the second line, like how would how would Racket know that that's a continuation of the function definition? But yeah, I don't know. It's just really, it's a different way of trying to visually parse this stuff and see like where does one thing stop and one thing end.
Yeah, it's all because of the parentheses. So it's going to know that here is open parentheses, here is closed, here is open, here is closed, and this one is closing. So in the end, everything is closed by the parentheses. But it still is kind of weird. Then everything is an expression. And just because we can do this doesn't mean we need to do it, but we can do something like this. So we can define a function, sum or by, and we're going to pass a parameter num. And here we're going to say that if the number is lower than 5, then we're going to grab 10 and 20 and sum them. Otherwise, we want to multiply them. So we can do that. It's not, I don't think it's recommended, but we can. But that leads us to another example, and I want to share my screen just to showcase this, which would be more interested probably. So here's Dr. Racket. This is an IDE that comes when you install Racket. So you install Racket and you're going to have the IDE, which is pretty cool for doing Racket. So here we're going to say define. We're going to call it my lambda. So we're actually going to create a lambda, which is an anonymous function. So we're going to say lambda plus 2, 3. And we're going to close the parentheses. So here's our function. So we're creating an anonymous function, but we are assigning it to a variable. So in this case, my lambda is going to be bound to that anonymous function. And this means that we can do something like this. By, and here I'm going to call my lambda. And then here I can say 8. So what this is going to do, it's going to call the result of my lambda, and it's going to multiply it by 8. So if I run it, we have 40. So 5 by 8, 40.
So let's see if I even stand a chance of understanding this. It looks like basically that line 5, you're calling my lambda, and my lambda always returns 5?
Yes.
Okay.
Because what we're doing we are creating an anonymous function or a lambda, which is this one here, but we're assigning that to a variable, which is my lambda. So every time we call that variable, it's going to execute the lambda and it's going to return 5.
Okay, and then you work outward from there on line 5, and now you're taking the result of that and multiplying it by 8.
Exactly.
Okay.
So it's just something that you can do with this kind of structure that Racket has. So as everything is an expression, you can do things like that. Which can be useful, might not be useful, you can do them. And then let's gonna take a look at a real examples, the Fibonacci list. Like if you pass 5, you're gonna have 0, 1, 1, 2, 3, 5. So we're gonna see how that looks like. Share my screen because they're obviously pretty small.
Yeah, so this is looking at a Fibonacci implementation, is that right?
Yes, exactly.
Okay.
So
Yeah, so it might be worth just mentioning quickly again, like you just explained, for example, if you pass in 5, so Fibonacci, we can probably walk through that just a little bit, say like, you know, your Fibonacci sequence, how does it start? It's like you've got 0 plus 1 equals 1, and now you add the 1 to the end of the list, and the last 2 elements would have been, first you had 0 and 1, then you added a 1, now you've got 1 and 1 are the last 2 elements, you're going to add those together in there too. That you just kind of keep that going.
Mm-hmm. Exactly. So here we defined the function, which is fib, which is going to take a number, or the number you're inputting, for in this case 5, and then it's going to take a and b, which is going to be 0 and 1, because it usually Fibonacci list starts with 0 and 1. So what we want to do here this cont stands for conditional. So we basically want to say if the first or the second parameter, which is a, is equal to 0, then what we want to do is we want to grab an empty list. We're going to sum a and b. And we also want to make another empty list, concatenate it with b, concatenate it with a, and then call the Fibonacci function again. But using sub1, which is going to subtract 1 from the number. So we pass 5, then it's going to become 4.
So it might be worth explaining some of these keywords real quick. Like I'm guessing append is the concatenation.
Const is concatenation, exactly. So const is concatenation for list. So we had string append, which concatenates strings. Const is going to concatenate list.
Okay, so does the append add a new element to the end of a list then?
Yes.
Okay.
Mm-hmm.
Right, so that would be kind of like a push in JavaScript.
Yes, exactly.
Okay, got it.
And then cont is for like kind of like a bigger conditional, like a switch probably, because here you're comparing like if a is equal to 1, or it's if the number is equal to 1, or if a is equal to 0, or if a is lower than 0. And that's kind of like a switch in other languages.
Yeah, if I squint my eyes, I can kind of like, it looks like a switch. It's a switch statement.
Yeah. And then sub1 is just gonna subtract 1. So we don't have to do like number minus 1 or number is equals to number minus 1. The sub1 is going to do that for us. And then, so when we call fib, passing a number like number 501, it's just going to call the fib function recursively until it gets the result. So if I run this, I do on parentheses, show fib, and I pass, for example, 10, it's going to return 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So we just grabbing, for example, 21 plus 34 is going to be 55. 13 plus 21 is going to be 34. 8 plus 13 is going to be 21. And going that all the way down to 0.
And you showed me you did a pretty extreme example.
Oh, yeah. Actually, I don't know if we can do it. It's gonna look crazy, but I think it's worth showing.
You're gonna run it?
Yeah, probably we're gonna see the end of it, but you're gonna see how it looks like. So we're gonna pass 5,000. And the thing is that Racket is not going to overflow, it's not gonna break, it's just gonna continue until it shows us the very last number, which is actually 1,045 digits long. So you see, it's just gonna keep going and going. It's gonna take a bit. But unlike other languages, it's just not going to break. It's just going to keep going and going and going until it got it.
Okay, yeah. I doubt we'll sit here and watch the whole thing. I think you mentioned that it took like 5 minutes to do this last time.
Yeah, something like this. So I'm going to stop sharing my screen just for a second. So just we can talk a little bit. But once it's done, if we have some time, I'm going to show it.
Okay.
But then, yeah, that's pretty much it. I mean, the idea is that everything gets surrounded by parentheses for some reason.
And this is where I just got to ask, why oh why would one do this to themselves? Like, I mean, it's kind of, it's interesting. I'm sure there's really good reasons for this, but they're not apparent to me on the surface. I found, like, just kind of having a look at it, like it's obviously a pretty heavy syntax to parse. So you can kind of see, after seeing just even a basic example of like implementing Fibonacci, right?
Yeah.
Like how many parentheses you end up using, which is, I'm sure for people who love Racket and Lisp style languages, I'm sure they get tired of hearing that criticism pretty quick. But I'm just curious, like, I mean, you know, it seems like Lisp inspires a lot of innovation in the programming language space. So there must be something to it. And I'm curious, like, what do you see as potential benefits or use cases for a language like Racket?
Well, I mean, I haven't used it very much. But I know that, for example, Naughty Dog, the one that created Uncharted and Crash Bandicoot, use it as a scripting language. And Square USA, that did the Final Fantasy movie, using for real-time CG content production. And even it was used at MIT to teach programming. Obviously, they teach it for Python, but they used to teach Racket, which is pretty cool.
Yeah, it's super interesting. So, I mean, yeah, I guess I was interested to hear first. Like you mentioned, whoever the creator of Crash Bandicoot is, they use it as a scripting language.
Mm-hmm. Yeah, I'm not sure how, but I mean, Racket is like you saw. It's like modular and meta and object oriented and functional and everything. So that allows you to actually create DSLs. So a lot of people use Racket just to create like subdomain languages, like
DSLs for our
Yeah.
viewers is domain specific languages.
yeah. So they create their own languages, grabbing some things from Racket here and there, and they create something new that they can use. So supposedly it's pretty good for that. I haven't done that, but people claim that it's just perfect for that. So it's a nice language to learn.
Okay. All right. Well, thanks for walking us through this. Anything else you want to share about Racket and others like Lisp style languages before we close out today?
No, well, really, I wish the Fibonacci example has ended by now. It's still working. So let me quickly share my screen just so people see that this actually keep running. You see? So if I go all the way up, it actually doesn't allow me because it's just going down and down and down and down. But
yeah, I was gonna suggest that you share the final number in a tweet, but obviously that won't be possible because the number's gonna be too big.
Yeah, no, it's too high. So that was completely extreme example. But at least it showed that Dr. Racket is capable of handling like really huge numbers.
Yeah,
which is nice.
All right, cool. Well, look, thanks for this is a one in a growing series of you introducing us to new programming languages and different programming concepts and paradigms.
Mm-hmm.
So if folks want to kind of check this out, if you're not watching on YouTube already, this is the place to go. Go over to YouTube, subscribe, hit like, comment on things. We'd love to hear like if you have things in mind. Obviously, a lot of what we do is very related to Nylas and our email and contacts and calendar APIs, but we do like to go off into some of these like broader topics just to see like, what's possible. And sometimes I get my mind blown in real time by our developer advocates, which is always a fun thing for me. So check it out on youtube.com/c/Nylas. And we do a couple of these a week.
Yep. And just let us know if you want to see something, if you're interested in a programming language or something regarding Nylas or whatever you want, just let us know, and we're going to try to do our best to do a live stream on that.
That's right. We'll absolutely do it. And if you want to check out all things related to Nylas and our APIs, developer.nylas.com. I'm sure we'll have some new live streams coming soon that'll show people how to do cool stuff with our APIs.
Yep.
Cool.
All right. Thank you, Ash.
All right. Thanks.
Good to see you. Bye. Take care.
Bye-bye.